Hi everyone, in this video, I would like to present our work PartDistill 3D shape part segmentations by vision language model distillation. I would like to give high-level introduction first. So, given a 3D shape, it can be point cloud or mesh data. We would like to segment this shape into the corresponding semantic part by using a text prompt that describes the semantic part. And this is the example of the segmentation result. To do this task, we leverage 2D vision language model. All the existing methods that use 2D VLM for doing 3D semantic segmentations, they first project the shape into the corresponding multi-view images here, and they feed these images into 2D VLM, and they get this result. They further propose a voting mechanism to aggregate these 2D predictions into the corresponding 3D segmentation here. However, doing this mechanism, it poses three major issues. The first issue, there are some invisible or undetected 3D regions in the 2D multi-view images. So for this particular region, they have no any prediction. And the second issue, there are some inconsistent 2D predictions. For example, this, and it gives a negative transfer to the final 3D segmentation. And the third issue is lack of knowledge accumulations across shape because they do not exploit the knowledge from the multiple shape. And by doing distillation, by using our proposed method, we can alleviate these three major issues. Now, I'm going to explain more detail of our method. So we have these multi-view images rendered from this shape, and we will feed these multi-view images to the 2D VLM. And then we have the 2D prediction. In this case, we try to forward distill. Forward means we distill from the 2D modality into the 3D modality. And in the same time, we also learn the 3D geometrical features. So by doing this, we can give a reasonable predictions for those invisible and undetected 3D regions in the 2D images. So that's why this method can alleviate the first issue. And then we also observe that not all the knowledge are reliable. So we try to improve the original knowledge by feeding back the knowledge from the student in the 3D modality back to the 2D modality. And we call this mechanism as backward distillation. Finally, we will have a better knowledge from the teacher, and we do again forward distillations from the 2D modality to the 3D modality. We apply this whole pipeline to a collection of shapes to accumulate knowledge from them, thus alleviating the third issue. And our method generalized to both bounding box VLM, for example clip, and also pointwise VLM, for example clip. For backward distillation, we compute the agreement between teacher and also the student knowledge. And then by computing this agreement, we can identify those of low quality knowledge and also those of high quality knowledge. For more details, we suggest to read our papers. And then by knowing this low and high quality, we try to suppress the low quality knowledge, for example, from this 0.7 into 0.1, and we increase the high quality, for example, from 0.6 into this 1. We experiment our proposed method on two datasets. The first is ShapeNet part dataset and also PartNet E dataset. And we provide the qualitative result as shown in this figure here. We compare with the recent state-of-the-art method based on the data type. It can be point cloud or mesh data, and also based on the employed VLM. It can be clip or clip here. And from this figure, we can see that our method gives a better segmentation result that can alleviate these three issues here. We also provide the numbers by comparing with the state-of-the-art. And from this table, we can see that our method can consistently outperform the benchmark method. So in this work, we present a cross-modal distillation framework that transfers 2D knowledge from a vision language model to facilitate 3D shape part segmentation. Our method generalized well to both bounding box VLM and also pixel-wise VLM. And our method carries a bidirectional distillation, which includes forward and backward distillations. That's all, and thanks for your attention.